The second of the general kinds of mathematical methods we use in Chem 68, actually also in Chem 51, are algebraic manipulations. A very simple example of that is a definition we will be talking about later for density. Density is defined. Density is equal to the ratio of the mass of a substance to its equivalent volume. And in algebra, usually rather than writing out words such as density, mass, and volume, we replace this with symbols. For example, D, where D stands for density, equals M, that's standing for mass, over V, standing for volume. And the point about an algebraic manipulation is I can give you two of any of these three variables, the three variables being density, mass, and volume, and ask you to find for the third variable. The essence of an algebraic solution to a problem like this is to not put numbers into a problem, but rather to actually solve for the symbols algebraically, and then after you've solved the algebraic problem, then plug in the numbers. That's usually an easier way to do it. For example, in this case, if I were to give you density and give you volume and ask you what the mass was, I would rewrite the equation, density equals mass over volume, and just simply manipulate that by multiplying both sides by 1 over v. That's really what we're doing here. If I multiply both sides by 1 over v, then notice that I take that back, of course. See, that's not going to work. Instead, what I should do is multiply both sides by v. So again, looking at this, if I have density equals mass over volume, and I multiply both sides by v, do you see now how the v's cross cancel on the right-hand side of the equation, leaving me a new equation that says mass equals volume times density. Notice that misstart I had there was perfectly valid algebraically. There's nothing wrong with taking that equation. Let me write it again for you. Over and multiplying both sides by 1 over v, but the whole point about this is it doesn't get you anywhere. I mean, if you continue with that, it would give you density over volume would equal mass over volume squared, and you see how that's not helping you. Whereas up here, we have an equation now that solves for mass, and I could plug any number in for volume and density and give my answer as mass. The other possibility here would be a situation in which, say, I gave you mass and gave you volume and wanted you to find density. Well, again, if you look at this, density equals mass over volume, but if I'm looking now for volume, one way to do this might be to simply take the inverse of both sides of the equation. If you did that, you could rewrite the equation as 1 over d equals v over m. This is, in a sense, a statement of the golden rule of algebra. You can do anything you want to an equation so long as you do it to the same thing to both sides. That was my error back up there, further back up here. It was nothing wrong with doing this, but it's just that it doesn't lead you anywhere. And that's the other part about algebra, is doing things that lead you somewhere. But in terms of a technique, anything is allowed. So I'm taking the inverse of both sides of this equation, flipping it, in other words, on both sides, because I'm looking for volume. Now notice if I multiply both sides by mass, then I have a new equation that says mass over density equals volume. In other words, here's the density equation written to solve for volume. Here's the density equation in which I'm solving for mass. The third permutation of this equation is simply the original equation we had, the definition. Any of these equations can be solved for, in this case, density, in this case, mass, and in this case, volume, by plugging in numbers. So as a concrete example, say I gave you a mass of 15 grams, and I gave you a volume of, say, 10 cubic centimeters, and I wanted to know what's the density, I would plug in my standard equation, the given equation. Density is mass over volume, which is 15 grams over 10 cubic centimeters. Divide 10 by itself, that puts a 1 here, and that gives me 1.5 grams for 1 cubic centimeter. We often write that as 1.5 grams / cubic centimeter, but what it really means is 1.5 grams over 1 cubic centimeter. On the other hand, if I had, for example, given you a mass of, say, 20 grams, and I gave you a density of, say, let me write that as mass is 20 grams, a density of, say, 2 grams per milliliter, and I wanted to know the volume, I would be looking at this equation here. But first I would have rearranged to get the statement that volume is the same thing as mass divided by density. A plug in here would be 20 grams divided by 2 grams per milliliter. Notice here in the units how the grams cross-cancel across the large fraction bar, leaving me units which are 1 over milliliters, which is milliliters. And so my answer here would come out as 10 milliliters. And that's, of course, an appropriate unit, milliliters, for the unit of